Hello everyone. Now we're in the third and final video for this module. This one I've entitled Decimal to Binary Conversion. So the text teaches this in using two basic methods, right? And let's just use what they came up with. I'm going to use the same value. So if the decimal value, right, I gotta have the pencil selected here, right? So the decimal value, right, decimal 57, right? That's what they use. That's 57, if you can read my writing. So let's just think about one method how you can do this, all right? We already talked about binary, and I'm gonna list their bits over here so we understand what each one is worth, right? So the least significant bit, remember, is 1. The next one is 2. The next one is 3. Oh, you believe it, I already made a mistake there. That's wrong. I'm sure you're all telling me behind the screen what the value there should be, right? The next one is what? 4. And then what? 8. And then what? 16, 32, and then we went to 64, right? We want to go up to the bit that's that's larger than this number, right? So if we just underline each bit, we have 1 here, 1 here, 1 here, 1 here, 1 here, 1 here, and 1 here, right? So how many times does 64 go into 57? It's going to be 0, obviously, right? Now, 32. 32 is less than 57, so we know that 32 will go into 57, right? So we simply write the value down here, 57. We write what is going into it, the 32, right? 32. We're going to subtract them. 7 minus 2 is what? That's 5, right? 5 minus 3 is 25, right? So you're left with 25. Does 16 go into 25? Yes, it does. So we say it goes in once. 5 minus 6 is what? It's going to be a 9, right? So does 8 go into a 9? Yes, it does. 9 minus 8 is what? It's going to be a 1, right? 9 minus 8 is a 1. Does 4 go into 1? No. Does 2 go into 1? No. Does 1 go into 1? Yes, it does. Left with a 1. So this right here I can circle it, right? It's not a circle, but there is your binary representation of 57. So practice this. Practice writing your bits in order, right? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. You can keep going. I mean, that's sufficient right there. And you can practice with other numbers. Let's do another one. Let's just, for the heck of it, do another one. What do you say? I'm going to delete that here. So let's just choose a number. Let's choose. Let's not go so high. Let's choose 17, just for fun, right? 17 decimal. That's what that D means, all right? 17 decimal. So what are we going to do? We're going to write out our bits, right? 1, then what? 2, 4, 8, 16, 32, right? We don't have to go any farther, right? Because 32 is higher than 17. So, how many times does 32 go into 17? 0, right? How about 16? It goes in there once, doesn't it? Right, 16. 17 subtract 16 equals 1, right? 8, did 8 go into 1? No. It's 4. Does 4 go into 1? No. By the way, that's a 0 there. 2 would go into 1? No. How about 1? Yeah, it does. It goes in one time, right? Left with 0. Here is your binary representation of that number. All right? This is one method they teach that is taught in the text. And generally, after you use binary for a while, at least this is what I always fall back on. I just write them out and do it. The other method that is taught is the divide by 2 method. And I think we went over that in class, but let's just give it a go here. Let's just get another number here, the 57, because that's what they did in the textbook, right? It's the divide by 2 method. Remember, here you're going to have your quotient in this column, and here you're going to have your remainder, right? R. So if we take 57 divided by 2, what's that going to equal? It's going to equal what? 20, what is it, 28? There's a remainder though, isn't there? 1. Because this is only 28, that's 56, right? So you have 1. So let's come down here. We'll rewrite that quotient here. 28 divided by 2, what's that going to equal? It's going to equal 14, isn't it? And your remainder is going to be what? Big fat goose egg, it's 0, right? Let's take this down here. 14 divided by 2. What's that equal to? 7. Any remainder there? No. 0. Bring your 7 down here. 7 divided by 2. What's that equal to? 3, remainder 1. Let's bring this down. 3 divided by 2. What does that equal? Right, that's equal to 1 with a remainder of 1. Let's bring this down. 1 div 2. What does that equal to? 0 with remainder of 1. Now, remember what we said. Pretend that this is a tree and it's falling this way. So your binary number is remember, this is your least significant bit, and this is your most significant bit. Your least significant bit is on the right-hand side. Most significant bit is on the left-hand side of your binary number. So if we just rewrite this, what it's going to be? It's going to be 1, 1, 1, 0, 0, 1. We're looking at 57, right? So that's 1, 2, 4, 8, 16. 8 and 16 is 24, right? 24 and 32 is what? 56. Plus your 1, that's 57. Yeah, it's all right. So there it is. And by the way, you can put a little b there, all right? So those are 2 methods. Let's do one more. Let's do the 17 that we did in the prior example, just to kind of make it complete here, all right? Let me write down the 17 for you. So 17 in decimal, right? So let's write your quotient here, your remainder here. 17 divided by 2. What's your quotient? It's going to be 8. You know what? I should have put remainder there. Maybe I tried to underline it. That's an R there, folks, and that's a Q there. Yeah. So 8, remainder 1. Do you agree with that? I can't hear you, but I assume the answer is yes. Now, bring your 8 over here, divided by 2. What's that? That's 4. The remainder is 0. Bring your 4 down here. 4 divided by 2 equals 2. R is 0. It's a 0, by the way, folks. boy, I can't draw worth means. There you go. We'll bring your 2 down here. 2 divided by 0. I'm sorry. That's 2 divided by 2. If I could do that. Yeah. What's that equal to? 1. Right? Let's bring this one down here. 1 divided by 2 equals 0. Remainder 1. What's this up here? This is your least significant bit. What's wrong with me today? LSB. And this one here is MSB. Right? Remember, the tree's falling down this way, right? So if you rewrite it, it's going to be what? 1, 0, 0, 0, 1. Right? 1, 2, 4, 8, 16. So we know we have 16 plus 1, it's 17. Makes sense. There's your number. So those are the 2 methods basically that are used to convert decimal to binary. I really hope this has helped you, and see you in class.